Hi, welcome to an Arduino step-by-step course by Robojax. A switch has at least two or more wires to connect one path of current or multiple paths of currents. In this case, as you see in this diagram, this is a symbol for the battery and this is a bulb. The two wires must be connected for the bulb to be turned on, and from this side we have a switch which can connect and disconnect, and the light will be on and off. And this is two wire of this one on this side is acting as that switch. And here I have actual bulb. This is a bulb for the car which has two wires. If I connect 12 volts, it will turn on. Now let's use the switch to turn this on and off. This is the bulb. The one side goes to the battery, and this side that goes to the battery. The other side goes to the switch, and from the switch we have another wire. So the switch has one wire goes to the bulb, the other wire goes to the battery. One wire goes to the bulb, the other wire goes to the battery, and this is a battery now. These two wires are the battery. Now the light is on, off, turns it on, turn off. Now what is a push button switch? A push button switch is the same as a switch, but when you press it, it connects these two wires, and when you release your hand, it gets disconnected. However, there are also this type of push button that when you press it, it disconnects the power. When you release your finger, it gets connected. So this is one of the most common push buttons, but it has a push button. You press it, release. It connects and disconnects. This push button, when you press it, it connects the circuit like this, and when you release it, it goes back like this. So it just completes the circuit. And for Arduino, most of the time people use this one, this type of push button. It has 4 pins, which 2 of them are used, 2 for one wire and 2 on the other side for the other wire. But for breadboard, this type with a 2-pin, long pin can be inserted in breadboard. This would be the best option. When you're buying it, make sure to get from this one. But this one also works with a plier. You flatten the pin. And then this can be inserted into breadboard. Or even you can get a push button, something like this. This is a push button switch. When you press it, release, it returns back. So in all cases, we are looking at a push button that has 2. There are push button switches that have multiple wires. When you press and connect it, it connects multiple wires. But in our case, we are just looking at single connection with 2 wires. To use a push button switch, for example, in our case, which we are going to use, we are using the push button with a pin 2 of Arduino. This is Arduino board, and this is a pin 2 of the board. We can do it one way in this configuration, which means from 5 volts, we put a resistor that is greater than 300 ohm. The resistor can be 300 ohm or higher, 10 kilo, 100 kilo ohm, doesn't matter, because this is just a connection of high impedance input, and the amount of resistor does not have effect. But if you go lower than this, every time you push it, you will consume a lot of current. For that reason, keep this high. Up to 1 mega ohm will work fine. Connect a resistor from 5 volts to pin 2. And then from pin 2, this is pin 2, we connect our push button switch. Our push button switch has 2 wires. One goes to pin 2, the other side will go to the ground of Arduino. And when the switch is not pushed, it's always high. The 5 volt is connected to pin 2 and it is high. Now when you push the switch, the connection establishes and pin 2 goes to ground or low. This is 0 volt when you push it. So the push button sends low when it is pushed. When you release it, then the high will be connected and then pin 2 will be high. The other configuration is this, that push button is from the lower section, it goes up to the positive, and the resistor which was here now is connected to the ground. So pin 2 is normally connected to the ground with a resistor, and push button is connected between pin 2 and 5 volts. When you push this switch, pin 2 becomes high, and when you release the push button, pin 2 becomes low, which is connected to ground. We'll be using this line, all of this as my ground, and all of this, the red on this side, as my 5 volts. I will put my push button in this configuration, meaning from pin 2 it will be connected to the ground. So first I will put my resistor, connecting it to 5 volts. This is a 1 kilo ohm resistor, and as you can see the color, brown, black. Brown is 1, black is 1, 0, and then red. Red means 2 because it is located at the third strip. Then it means 2 zeros. So 2 0 with 1 0 will be 3 0. This is 1 kilo ohm. To the positive, this is my 5 volts, and connecting it somewhere on the breadboard. Now this is from 5 volt, it's connected up to this point, and from this point, which will later on will be connected to pin 2, from this point I'm going to connect my push button switch to the ground. And this is my push button switch. I will insert my push button. One pin must be connected to this resistor, to any of these holes, and the other pin will go in here. Now like this, it has been inserted. The other pin of this push button is in here, and as I mentioned, it will go to the ground. From here it goes to the ground. Now this must be connected to the ground of Arduino, and this line must be connected to the 5 volt. Any point is good, we can just connect from here. Arduino has here one ground here, and one ground in here. I will be using one of the ground here and then connecting it to any of these pins on this side. So now the switch is connected through this wire in here, and from here it connected to the ground to 5 volts. I'm using this wire from 5 volts from here, connecting it to 5 volts of Arduino, which is at this point. Now this is connected. I could use also this switch, which I'm going to test it next. For more videos, please click on subscribe button or click on the icon on the right side of the screen. Thank you. Here is a sketch of Arduino. This is the setup function from here to here. Whatever occurs here, it will occur only once. And this is the loop from here to here, and these will happen continuously. Let me explain this one. Using the pin mode, we say pin 2 as an input. This is used because we have pin 2 dedicated for this push button. So we want to be able, whatever happens here, we want to be able to read or detect it. So we set pin 2 as an input, and then we put serial.begin. Serial is capital S, begin is small, lowercase, and then 9600 baud. That is the speed of serial monitor, which I'm going to show you. And then after that we say push button test. This is the text, will be displayed only once. Now inside the loop, we read the status of this push button using digital read, because this pin can be either high, which is 5 volts, or low, which is 0. So we use digital read. and then we put the pin that we want to read. So digital read pin 2. So this reads the pin 2 and the result is stored in here. We type int, which is integer, and then we put a variable to store the value. In this case, I typed it as push button value. You can use any other variable that you wish, but it cannot start with number. It cannot start with any of these reserved words. For example, it cannot be void, it cannot be loop, setup, pin mode, serial, all those things that are reserved. And you cannot have a space. So you can put upper, lowercase, or underscore. That will be fine. The result of this is stored in this variable. Now we didn't do anything, we just read the value. After that, we use the conditional statement. This is called conditional statement F, and this is the opening. As you notice, when I click my mouse close to this one, you will see square bracket around the other one, which is telling me that this is the beginning and that's the end. If I click outside, it disappears. If I put inside, you will not see it. Only if I put it in here, the square goes around the other one, or if I put it here, it goes around the other one, telling me that this is the beginning and that's the end. And this is how it works. We say if whatever is here is true, then do whatever is between these two curly parentheses. So do this, or whatever else we put. So we say if this is true, do this. What it does is it says serial print ln. It means print, and also new line, which means press enter. With it, button pushed. Now let me do, I'm pressing Ctrl and Z to undo it, and here also it shows undo, Ctrl Z, you can see it. So the value here, we say if this value is equal low. This time we used two equal sign. One equal sign is called assignment. The value is assigned to this variable. So this is being stored in this variable or assigned. Here we put two equal sign. That is a comparison condition. We check if this is equivalent to this value or it's equal. And if it is low, if the button is pushed, it will become low. As I mentioned, when you push this button, this becomes low. It is connected to the ground. Then we print serial ln button pushed. Now this will print for us. After this, it goes and waits for 100 milliseconds, and the loop comes back, again reads it and checks it. If it is true, it will print. If this is not true and button is not pressed, it doesn't do anything and it goes checks next time continuously. Let me upload the code. I'm connecting it now to Arduino. Now it's powered up. Now the last step, which I have not done, is from this point it should be connected to pin 2. I'm using this orange wire, connecting it just at the resistor, the line that is with the resistor and push button, and then connecting it to pin 2. Now this is connected. Make sure that the COM port of Arduino is selected and upload the code. Let me now open the serial monitor. You see push and then push button. The reason for that one is that Arduino was running continuously, and then this reset or interrupted the running of that to display the text. But I can also reset it using this push button here, the Arduino. Now it's clean and clear. It starts from here. Now let me push this. It says button pushed. As you see, this time it shows twice because it waits for 100 milliseconds and goes and checks continuously. If I push and hold it, you will see it continuously print because it reads it 10 times a second, 100 milliseconds per loop. And if I don't push it, because this is not true, this will not be printed on the screen. And when I click, the serial monitor goes down. It's here. You will see two of those, and then click, it comes back. If you accidentally close it, open it again, no problem. And again, you see P test, it just interrupts the process of current code every time you open the serial monitor. This was our configuration. Now let's move the resistor down and push button up. I will disconnect it from power. The resistor will go, instead of 5 volts, I'm going to connect it to this pin. Now the resistor from pin 2 is connected to the ground. From this point, which is connected to pin 2, this is now connected to the ground. Now the other side must be connected to positive. I'm connecting it to 5 volts. So the push button, one wire is connected to 5 volts and the other wire is connected to pin 2. In this case 5 volts and then pin 2. Now let's read our code. We connect it. Now if we open the serial monitor, it is connected to the ground continuously and it will say incorrectly that push button have been pushed. So we have to update our code, but let me just show you the code first. Run it. It says pushed, even though we have not pushed it. So we have to change this to high. And upload the code back to Arduino. It says push button test and it's waiting. When I press it now, it detects it. Even though we changed the status from low to high, because we changed the configuration, now it detects it properly. Now let me remove this push button from here and connect this push button, the 2 wires that this one has. One wire goes on this side, the other wire goes on this side, and here is my push button. Every time I push it, you will see here the new reading happens. If you want to make this fancy, we can also put else here, and then let's copy and paste it. Button not pushed. Then it will continuously print button not pushed, not pushed. So you know for sure that nothing has happened. And then when I press this, it will say button pushed. When I release it, it says not pushed. Pushed, not pushed. Now I'm removing this, and let me connect the other one so you'll see also this one as well. Here it says not pushed. Let me push it. Pushed. Remove my finger. Not pushed. Connect now an LED. Every time you push it, you want to turn on an LED. It's very simple, the same as before. And here I'm going to connect an LED to one of the pin. Let's say I'm using pin 8. I will connect this to pin 8 and this to the ground, and I'm going to put 1 kilo ohm resistor with an LED like before. First, let me put the resistor. I'm going to put a resistor at some point between the 2 points like this, and then connect this LED, the long pin, to the resistor, which is the anode. Connecting the ground from this pin of LED, the cathode, and here from this pin of LED, I will connect this to the ground in here, and from this side of resistor, I will connect this to pin 8. I will be using this long wire. From this side, I will connect it to pin 8. Now I will update my code in order for the pin 8 to work. Let's set pin 8 as output. Pin mode. pin 8 is set. And here now, when the button is pressed, we say pin 8 high. So digital write 8. And here we say digital write 8 high. Also, it will print the text and also set the pin 8 as high. So this pin become high and the LED will turn on. And here we have to turn that off, otherwise it will stay on. So if that is not pressed, here when the button is pushed, we print the text, and also we say digital write 8, which means set pin 8 high, and this will turn on LED for us. And this is a comment. I just put it with 2// this is ignored by the code. And then else mean if this is not true or the button is not pushed, digital write 8 pin 8 low. So this writes the pin 8 as a low. Let me upload the code, and I've opened the serial monitor. Button not pushed, and then if I push it, it will turn on, and also it will print the text. If this is annoying, you can just comment this out, and let me upload it again. So it will just turn the light off, and we know the button is not pushed, and it will not do anything. Now pushed, the light is on, the text is displayed off, button pushed, and otherwise don't say anything if you want. So this was how to use push button with a resistor. So this was the push button with a resistor. You can do the push button without a resistor using internal function of Arduino. Now this works only in this configuration, not in this configuration, the configuration that the switch is to the ground. So using the same, for example, pin 2, we can use this command. Instead of input, we just say input pull up. It pulls this pin up to 5 volts. This pull and up mean that 5 volts, it pulls it up. Unfortunately, there is no such thing as pull down with current Arduino. It just has pull up. So when you say pull up, it sets the pin 2 as an input and also sets it to 5 volts via internal resistance. Exactly like a resistor, but it is inside for us. It acts like a resistor, and our push button will be here. Now let's change that. First, my push button is connected to the ground, so I have to connect my push button from here to the ground. Now this is connected. I'm removing the resistor. The only thing that you need is push button should be one side to the ground, the other side to pin 2. So push button, one side is connected to the ground, the other side from here, it's connected to pin 2. And then we don't need the 5 volts here. I'm just removing it. Now let's update our code. We type input underscore pull up, and that's it. This will eliminate using of a resistor, and let's change it to low, because when you push the button it goes to ground or to low. Let me upload the code. Open the serial monitor. Now the new code is uploaded. Let's push it and see here, and pay attention to the light. Button is pushed, LED works. Now let's see if we do not have a resistor and this is not input pull up. Let me remove this, upload the code. Now the light is on. When you do not push this button, it randomly goes on and off because if the resistor is not here and internally it's not connected, the resistor, or externally, this pin randomly goes high and low, as you can see it. Whatever noise comes, but when you press it, for sure it will be high. Remove it, it's off, but randomly it will go on and off. So this resistor either externally, or if you use pull-up, internally must exist in order for this push button to work properly. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.